Let's have a look at collisions. I've got this program most of which I've shamelessly stolen from a student, and let's have a look at the different parts. So you've got your player sprite here, and you've got a block here, and that's a wall. So we're going to look at the collisions and how we can detect the player is hitting the wall and what we should do about it. So let's just have a look at the code, familiarize ourselves with this. So we've got a few variables to start with. We've got the game. Now this is what's going to be called when the program runs and it just starts the game loop. So the game is where all the magic happens. First it sets everything up, it sets an all sprites group, so all the different sprites of the thing. It also sets up a list of walls and an all walls group, so that's where all the walls are going to be added, and obviously we put the walls into the all sprites as well. So the draw is just saying, okay, everything which is in all sprites, put on the screen, and then we've got the game loop. Now there is various bits of code which is coming out, which I'll get back to later, but the main thing that this is doing is it's going through the events, it's got a mouse down, and that's about it. It's also calling update on all the sprites, and then it's drawing it and rendering it to the screen. If we look at the different sprites that we've got the wall, and the wall really doesn't have much in it. All it's got is the init, because it's not going to be updating, it's a static wall, it doesn't change. We're just filling it with a color, so creating a 100 by 100 square surface, filling it with a color, and saying, well, that's our sprite, and then we're putting it in the coordinates 600 by 200. So yeah, if we create 100 different walls, they're all going to be in exactly the same place. Not ideal, but that's fine for what we're trying to create. I'll come back to that next line later. Entity, that is our main character for now. You'll notice it passes in game to the constructor. So when we create the player, we're passing it self, which is the game. That means that the player object can access things from the game object. Makes it a bit easier to access all the different things. So we're just storing that. We're loading the image. We're creating a 200 by 200 surface. Let's have a quick look at that. So a 200 by 200 box. And then we're putting the image onto that box in position 0, 0. So that is, you're creating a box which is 200 by 200, and then on that, starting at that position, you are creating the image. Okay, so that is essentially what that line's doing. Okay, then we're getting the rectangle of that. So we're just letting the computer to calculate the rectangle, and we're putting the center of it in the center of the screen. So that's centralizing the player into the center of the screen. Okay, then we've got current position, we've got current speed. We're not using a score. And what we're calling every time is update. So what does update have? It's got entity movement, and that's about all we're looking at the moment. So entity movement is grabbing the key presses, saying, okay, is the A or D key pressed? If it is, change the current speed, and then update the position. And updating the position is just changing the X and Y. So you update position, it says, okay, my current speed is this, let's add that to the current position on the screen. So if the current position is positive on the X, this image will just move to that way. Then the rectangle gets updated with that position. And what I've got here is something which is just checking to see if it's collided. Now this is the easiest way to do collisions. All you're saying is if sprites collide self, so that's the player sprite. In this case, I'm calling it from the entity itself. And then I'm checking to see if it's colliding with anything in this group, and the group which I'm checking is all the walls. Now if this was more of a game, there would be quite a lot in there. As it stands, there's only one sprite in there. So it's checking to see if the player sprite will collide with any of the walls. This false can be quite useful. When I was creating Snake, I changed that to true, and essentially what it does is when it collides with one of these, do you want the thing it collides to die? Be destroyed. And this is quite useful if you're sort of doing bullets, so you can check if the player is hit by any of the bullets. If it is, this will return true, but the bullet will be destroyed, because generally you don't want bullets to go through characters, depending on what your game's doing. So let's have a quick look at this. So the A and D moves the character forward and back. I'm not concerned with the y-axis at the moment because I'm just demonstrating things. And what this is going to do is if it's colliding with the wall or any of the walls, any of the one walls, then it's going to print hit the wall. Okay, let's have a look. So moving around, we've got nothing coming up. The minute we get to that, there we go. So it's hit. And we can see right the moment where that's hitting, so that's not touching. That is touching. So we can see it's going right to the edge, which is fine. And that is the easiest way to do collisions, and we've got that working. Okay, let's have a quick look at the main event again. So we're running the game loop, and what we're checking on a global level is the mouse down. And when we got the mouse down, what we're doing is we're just printing click. Then what we're doing is we're returning the result of this command. And we're saying, okay, look at the rectangle of the player, which is this rectangle. And does it collide with this point? So we're giving it an XY position and saying, does that collide with this sprite? And the XY position we're doing is just the position of the event, so where you've clicked. So if we click here, you can see click and 0, so false. No, it's not colliding with the sprite. If we click on here, you can see it's a 1. Therefore, we are clicking with the sprite. Awesome, so we've got collisions working on both moving it into another sprite and on clicking. Now the first thing which I want to look at is what should we do when this collides, because I'm assuming this isn't the behavior which we'd expect. Generally, characters don't walk through walls. So how can we make that behave as we would expect for a game? Now let's have a look at where we're updating the movement, because I put that command in there for a very good reason. So we've got we're moving the character, so this is the first point at which we're moving the character to the new location. We're updating the X and Y of the sprite, and then we're checking to see if it collides. Now what we want to do is move it there. If it does collide, we want it to go back. The easiest way to achieve this is to essentially copy this code and do it in reverse. So we moved it, it caused a collision, so we're undoing what we did. So we're moving it forward. If there's a collision, we're moving it in the opposite, so the minus on all of those, and then just re-rendering it exactly the same way. So the X and Y moves still work, but when we hit that, we can see that it moved back, and it won't let me move into it. So it's just using the collision to stop it moving. Awesome. Now this looks all good for now, and everything seems to be working, but what I'm going to do is I'm just going to change the position of the wall from 200 to 300. Okay, so the wall's slightly further down, and the collision should still work. So let's move into the block and see what happens. Okay, that's saying that there's a collision there. Now you may have had it on some computer games where you've got your character and maybe a projectile has come along and it's gone really close to you, but has not actually hit you, yet you still lost a life. Maybe you've had it so you've got a boulder or an object or something, and you've got a block which the character's pushing, and that's sitting on top of the block fine, and you keep pushing it along, and then eventually you get the block sitting there, and it's sitting right on the edge, but it's not actually touching. Now what's happening here is that you've got the bounding box. So you created the rectangle on this, and it's the same on this. So this is creating a rectangle, like so. And then what we've been doing is we're checking to see if it collides with that rectangle. And apologies for the dodgy line drawing. So we can see in both of these cases we do have a collision. Therefore we should lose a life. Therefore we should stay on top of that object and not fall. That one I've seen a lot in sort of puzzle games, and exploit as much as possible just to get as far as you can in order to jump on the box and get furthest. Now this is all good and well, but this often isn't what we want. Sometimes we want to check exactly, and there's a couple of ways you can do this. The first way is essentially make the box smaller. So instead of having the rect which is from the image, what you can do is you can say that it's slightly less. So we're drawing the rect to there. Now this misses. The upshot of that is that if you skim something across the top of the head, that also misses. Now for a game, quite often players will want the benefit of the doubt. If this happens to be a hit, then people get annoyed that, hang on, that isn't fair. If the bullet goes across the top of the head and it doesn't give you as losing a life, then you feel like you've got away with one. So that will make the player feel happier rather than this, which will make the player feel conned. Similarly, if you did that there, you create a smaller blocks. This will then fall, and it's up to you whether that's what you're trying to achieve. Now that's the quick and dirty way, and the thing with these rectangles is that they're really quick to computate. It's really quick for the computer to run those collision lines. This collide is really quick for a computer to be able to run that. The alternative, well, you can also do it with circles, so this one might be better doing it as a circle, and that can be reasonably quick to calculate as well. You can, however, do it by pixel. You can do it, to get it spot on. And what that's called is using a mask. Now when we use a mask, what we're essentially doing is we're drawing an outline of our shape. So we're checking every single pixel. Now you may have it that you've got a face on there and all the rest, and different coloured features and all the rest. The mask does not care about any of your details. All it cares about is there stuff or is there not stuff. So all of this would now appear as one. Before there would be a hole where the head is, in the middle. Now it's going to be treated identically to the rest of it. So okay, so how can we create this mask and how can we actually compare it? The lines are actually really simple. Because we're using entities, we're using sprites, and we're using all the sprite functionality. All you need to do is set the self.sprite object parameter. And to do that you say, okay, pygame.mask.generate a mask for me from the surface self.image. So it's taking this image and is creating a mask. Now for this one, it's going to be pretty much identical to the square. We're also doing this for the player. And when we update it, we're updating the mask. Because as we rotate, as we move, we want the mask to be changing. It doesn't particularly help us if the mask is in one position, the mask is like this, and you've moved so you're pointing this way. Your gun would be outside the mask and all the rest, so it's not particularly helpful. So these two lines have created a mask for each of the sprites. Now we need to actually say, okay, what collisions are occurring between those masks. And it's a very similar line to what we've already got, but as you can see on the commented one, all we're doing is we're adding pygame.sprite collide mask. And we're saying, how are we checking this sprite collision? And we're checking it by mask, not the default, the normal way, which is just checking the rect. So if we look at that line instead, now if we move this across, we can see that it's going right up to the edge of the character. Before it was getting the collision there, which isn't ideal. Now it's going right up and it's pixel perfect. So that's fixed it. Be very careful though, because this is highly expensive. And what I mean by that is that this is taking a lot of CPU time in order to do it based on the mask. Think about writing the maths by hand. If you want to check to see if a point is within a box here, you just need to check, is it less than this and more than this? And the same on the y-axis. Whereas now you have to check every single point, is that contained within this image? So it's very expensive, and if you do a lot of this, then it will slow your game down. What you can do to get around that is combine the two methods. Now what it's doing is it's doing the rectangle collision check on all the sprites. In this case, just the one of all of the walls. So it's doing the collision check, and then if that is the case, then we're doing the mask collision, and then we can change it so it's just that sprite and so on. Okay, so that's all good and well for moving into things. Now let's have a look back at our clicking. So we had that as 0, so that's not clicking on the sprite. Very good. That's 1. Awesome. Now what about this? It's saying that even that isn't, that is. So we've clicked on the player there, which I don't think is what we're after. So we can use this same mask theory on mouse click. So let's have a look at the game where we're doing the click. What we've got at the moment is we're looking at the rectangle and are we colliding with the point raised by the mouse. We've got this line which is quite useful. So what we're saying is the mask of the player. Remember we created the mask for the player here. So it's doing this mask dot get at. So it's saying, is there a collision at this position? And what we're feeding in is the position which we're checking. Now, we've got a little bit more going on here, because the coordinates which it's thinking about isn't the global coordinates. So if I just get a new image here, we have our rectangle here, we have our character here, when we do a check with this method, get at, what it's using as a reference point is this point. So if we say 100, 100 from the main thing is here, when you're calling get at and you call it with 100, 100, it's saying, okay, it's this point here. The event.pos, or the mouse position, is based on the entire screen. The get at is based on just this image. So if we check, say, a coordinate here, let's say here actually, if we use the mouse position, that may be, well, if we look at the pixels along here, that would be, say, 300 by 200. That's what the mouse would raise. However, when you're referencing it for this mask, 300 by 200 is down here somewhere, which is off of the mask, and therefore it will throw an error. So we need to center it to this point as opposed to this point, and that is what I'm doing here. So I'm taking the event position, so 300, then I'm subtracting this number, so 200. So 300 minus 200 is 100. So 100 from there, and now we're working in the right area. And we're doing that for the Y position as well. So now wherever we're clicking, it's doing it relative to this. That's all good and well. However, if I do this point over here, say 450, it's taking it from here, which is 250, so it's still going to be off the mask. And this particular command will throw an error if it's off the mask. So I only want to be checking this if we've clicked in this rectangle to begin with, which is also a nice way to optimize it so you're not checking too much. So what I've got here, if it's colliding with the rectangle, then check to see if it's colliding with that particular point. So let's run this again. So now we've got the click off, which is nothing. We've got the click on it, which is 1 and 1. So this is the get at. So you can see it didn't bother checking with the mask on the first one because it wasn't clicking in the rectangle. This one it was, and it found, yep, it's a hit. Now if we try this corner, we can see that it is colliding with the rectangle, but it's not colliding with the mask. We can even try in here, And in here it's not colliding with the mask, although it is colliding with the rectangle, which is excellent if we want to check for clicks on complex shapes. Okay, that is basically what I wanted to cover. So what we've done is we've got a couple of sprites. We've created a mask from the surface, so either from the plain rectangle or from the image, which is loaded from a graphic. When we're updating the sprite, moving it, rotating it, whatever, we're updating the mask again, so that that's always up to date and always the latest mask. And then what we're doing is we're doing a collision check with the PG Sprite Collide mask, or we're doing a collision check with mask.getAt. Now there are many ways to do these different things. This is just one particular way. Now this is how I was doing my checking. Okay, how do I sprite collide with the mask for the mouse? And that gives me all sorts of useful information. Detect mouse event on masked. That was quite useful, and the first answer was get at. So they check for collide point and then they check get at, which is exactly what I've done here, and they've done a nice little code snippet to help. I've also looked at the masks and looked at the actual get at and what that does. And you can see on the get at, it wants an X and Y, and it will return 1 if it's in the mask and 0 if it's not. It's always going to be an integer, and it will raise an error if it's outside of the box. So this is giving you all the information. And this is just a simple Google. Sometimes it takes a while to interpret it, but all the information is there. So here we've got the mask and how you can create the mask from the surface and what that means. So all this is giving you the information that you need. Then you've got, okay, the collision, checking the collide of the mask. You've got all sorts of information in here which is well worth looking into. So the upshot, there's some basic information for you. There's plenty more on the internet, and Googling it does reveal a whole load of information. So for your project, you are expecting to do a bit of research, figure out what's going on, figure out how it was working and all the rest, and that gives you something nice for your write-up as well. Okay, I hope that helps. Let me know if there's anything else which you want me to cover, any other little snippets of code which may help. Best of luck.